This video is about 11 different terms that relate to matter. Matter is very important in chemistry because that's really what chemistry is all about, is a study of matter and how matter changes and why matter changes. So what I'm going to do is give you these definitions and specific examples, and I want you to know the definitions regardless of the way the book has these definitions. Because there are a lot of definitions in this video, every time I finish reading a definition, I'm going to say pause. And that means just to pause the video. That way you can make sure and make sure that you have that definition before going on to the next one. Well, if we're talking about terms related to matter, I guess we first ought to talk about the definition of matter. Matter involves two different things. First off, it's anything that occupies space, and the other requirement is that it must have a mass. So the way your book says this is matter is anything that occupies space and has mass. Pause. The next term on your sheet is elements. Your book defines elements as just that which cannot be broken into simpler substances. So just know that elements cannot be separated into simpler substances. Pause. Compounds is the next word on your list, and compounds are just atoms of different elements that are chemically combined. For example, water is considered a compound. It has hydrogen atoms bonded to oxygen atoms, so that's why it's a compound. Again, two or more different atoms that are chemically combined. The next term on your sheet is molecule. And your book gives a definition of molecule, but I want you to know the following definition. It's like a compound. It's two of the same element bonded together. For example, oxygen gas is O2, so it's that same element oxygen bonded to itself. Another example of a molecule might be N2. So CO would not be considered a molecule because there are two different atoms there. That would be considered a compound. Pause. There are two types of mixtures that you need to be familiar with. One of them is called a homogeneous mixture. And these mixtures are just the same throughout. In other words, you can't tell it's a mixture by looking at it. An example of this might be a glass of salt water. Because in salt water, you can't even tell that there's salt in the water. So it's considered a homogeneous mixture. The second type of mixture is called a heterogeneous mixture. A heterogeneous mixture is the exact opposite of homogeneous. It means that it's not the same throughout. And here, if you can tell it's a mixture just by looking at it, then it's probably a heterogeneous mixture. An example your book gives that I like is Rocky Road ice cream. When you look at Rocky Road ice cream, you can see it has ice cream in it. You can see it has nuts in it and marshmallows and a lot of other stuff there. So just the fact that you can tell that it's a mixture means it's a heterogeneous mixture. I want to give you one more example of a homogeneous mixture before moving on, and that's air. Your book goes into detail with air. Air contains a lot of different things. It contains the oxygen that we breathe and need. It contains nitrogen in it. It contains carbon dioxide, water vapor, has a little bit of argon, has about 10 or 15 different things in it. But the point I want to make about air is that if you look at air, you can't tell that it has all of these different things inside of it, which makes it a homogeneous mixture. The next three terms on your list are solids, liquids, and gases. A solid is something that has a fixed shape and volume. Pause. A liquid, on the other hand, has a fixed volume, but it always assumes the shape of its container. And you can see here, water is assuming the shape of the Erlenmeyer flask. I like this picture in your book about the different states of matter or different phases of matter because it shows you things on a macroscopic scale as well as a microscopic scale. And understanding the microscopic scale can sometimes help us understand how we see things in nature, which I'll show you in just a minute after going through this next definition. The next definition of gas is gas. And a gas has no fixed volume, nor does it have a fixed shape. So typically gas molecules are far apart from each other. Before going on, I want to go back to a solid here, and I want you to notice something. The way water forms a solid to make ice, you can see here that it makes these kind of hexagonal structures, and it's actually the air that's inside that causes ice to be less dense than water, and that's the reason why ice floats in your glass instead of sinking to the bottom. It's because there's air that's trapped inside the ice crystals. Understanding that ice is a hexagonal structure on the microscopic level can help us make sense of things on the macroscopic level that I'll show you on the next slide here. I have here 4 different snowflakes, and what I want you to notice is the number of points that each snowflake has. For example, this very first one here, there's 1, 2, 3, 4, 5, 6 points. Those 6 points come, again, from the fact that water has this hexagonal structure on the microscopic level. And you can also see kind of a hexagonal format here. There's kind of a hexagon, and each point of the snowflake is also kind of a hexagon. And in this next one, we'll call this one number 2, you can see 1, 2, 3, 4, 5, 6 points again. And it's very, very hexagonal in its structure, including all of the points. Those are very hexagonal. Now let's look at snowflake number 3. There's not really a lot of hexagon here, but what you can see is that for sure it has 4 different points to it, and that's because of this structure that water has to form in order to make a solid. Now this next one, we'll call this snowflake 4. Again, we have these 6 points, and this one is a little bit more hexagonal in its structure, and that again comes from that hexagonal structure of ice. I have 2 more pictures of snowflakes on the next slide, and then we'll move to the next topic. Okay, last 2 pictures here, we'll call these number 5 and number 6. And again, I want you to notice the hexagonal structure and the 1, 2, 3, 4, 5, 6 points, and the hexagons at the end of each point for this snowflake. And let's look at snowflake number 6. This is obviously a hexagon in form, again from that microscopic view of water. The next term on your sheet is electrolysis. The setup I have shown over here is an electrolysis setup. What this setup does is it actually changes water into its bare elements, which are hydrogen and oxygen. So one side is filled with oxygen gas, and then the other side becomes filled with hydrogen gas, and it's powered by this battery. This is a chemical process, and you need a chemical process in order to separate out a compound. And remember, we said that water was a compound because it had 2 or more different elements bonded together. Anytime you want to pull those elements apart, you will always need a chemical process to do that. The next term on your sheet is distillation. This is a distillation setup. Distillations are typically used to separate out homogeneous mixtures. So if we have a homogeneous mixture, we can use distillation. And in distillation, example here, this is salt water in this round bottom flask, and we're heating it with the Bunsen burner. And what's happening is all the steam is coming up, and then it's condensing along the sides of this condenser and dripping through here, and we're getting the water out here. And you can imagine once all the water comes over, the thing that's going to be left down here is just the salt. So we'll have a pile of salt that's left over once all that water comes out. And that's how we can separate out this homogeneous mixture into its components of salt and water. And again, the water is over here, and the salt will be left over here. This is the last term on your sheet, and it's filtration. I think most of you guys have done these in labs before. What a filtration does is it separates out heterogeneous mixtures. So here we have a mixture of solid and liquid, and we have a filter paper right here, and as you pour that in, the filtrate or the liquid component is coming down through the funnel down to the bottom, and all of the solid stuff is getting stuck in the filter paper, and that's how we're separating out the solid from this liquid. Again, what's otherwise known as a heterogeneous mixture. It says determine if the following is a mixture or a pure substance, and then if it is a mixture, determine whether it's homogeneous or heterogeneous. So let's look at the first one, multivitamin. A multivitamin, just the fact that it has multi in it tells us that there's a lot of different vitamins, which means it's definitely a mixture instead of pure substance. And now we have to determine whether it's heterogeneous or homogeneous. This would be a homogeneous mixture, and I would say it's homogeneous because if you were given a multivitamin, you probably wouldn't even know it's a multivitamin, so you can't tell it's a mixture. And that's really the test for a homogeneous mixture. If you can't tell it's a mixture, it's homogeneous. The next one on your sheet is a Spanish omelet. Okay, I found a picture of a Spanish omelet on the internet, and I think you'll agree with me, you definitely can tell that there are things in here that are not part of the egg. Just the fact that you can see that it's a mixture by looking at it makes this a heterogeneous mixture. The next one is diamond, and you may or may not know this, but diamond is made totally and completely out of carbon. There's nothing else in there but carbon, which makes that a pure substance. The next thing is gasoline. Gasoline is actually a mixture. The fact that you probably didn't even know it was a mixture makes this a homogeneous mixture. The next one is a jar of jelly beans. So here's our jar of jelly beans, and just the fact that you can tell that there are different colors of jelly beans in here, we know that it's a mixture, and we know that it must be a heterogeneous mixture because we can tell that it's a mixture by looking at it. There are two more left on this example. There are margarine and copier paper. Margarine, believe it or not, is a mixture, and you may not have even known it was a mixture, but the fact that it's a mixture and you didn't know it was a mixture makes it a homogeneous mixture. And copier paper is also a mixture. It's made out of a lot of different things. And again, because you may not have known that it was a mixture, it is a homogeneous mixture. Now, if you're talking about copier paper in which you can see the little filaments and the little pieces of black stuff inside of it, then that might be a heterogeneous mixture. But usually bleached copier paper, you can't tell all these little tiny things and details in the paper, which makes it a homogeneous mixture.